Welcome back. We now have a case study on how to make your project vision come true with Precast, the journey from architectural renderings to actual buildings. Thank you so much to our sponsor, Elematic. Let's now welcome our next presenter, who with more than 20 years of experience has contributed to building solutions and major precast concrete projects in Europe and the Middle East region. Let's welcome the area director at Elematic, Curt Lindroth.
And ladies and gentlemen, everybody who's listening, I'm very happy to give a presentation regarding how to make your project come through with Precast, going from the vision to the actual buildings outside. The presentation covers, of course, a brief introduction to Precast concrete, but then also going into a case study. During the presentation, I'm going to thoroughly run through the slides, and afterwards you will have the possibility to ask questions, and I will assist by answering them. As mentioned, I'm Curt Lindroth, and in Elematic, which is a company providing turnkey precast concrete factories and also solutions for building in precast concrete. Precast concrete construction is actually a business choice, and it's possible to adapt in any type of buildings and in building projects. Quite typically, a building project does not only consist of one type of material or one type of surface finishing. It can be a combination of different material, and the combination is always something which is making the environment more living and interesting as well. As examples of the precast concrete buildings, partly, for example, in Dubai, we have the Burj Al Arab. And for example, even in Burj Khalifa, they wanted to have some foundation blocks in precast concrete because that was possible to monitor when it comes to quality assurance from day one. So there, they didn't want to have actually the risk of pouring something which was not controlled according to standards and specifications when building the world's tallest building. Precast concrete can be used in different ways. Some buildings are actually built by load-bearing walls and hollow-core slabs in the combination with the interior walls, load-bearing and load-bearing, staircases, elevator shafts. Also, it's possible to use columns and beams and precast concrete slabs as cladding. And it's possible to, of course, have short span columns and beams in a way copy an in situ type design. But then again, then there would be much more parts. So the most efficient way of using precast concrete is to utilize the long floor spans and load-bearing walls, especially for lower buildings, at least lower than some tens of stories. Precast concrete represent also low life cycle costs. And the life cycle costs represent actually the fact that the maintenance costs of the precast concrete building is lower than using conventional or other solutions. It is possible to actually state for how many years the precast concrete building should be sustainable and how many years the structure should be rigid. And for example, in Finland, there is a building which was guaranteed for 200 years by the contractor. The production of precast concrete buildings is, of course, at the factory mainly when it comes to producing the parts, and that means that the working environment for the personnel is safer and also healthier. It's under a controlled environment. It represents savings in material, resources, and time. And concrete is actually the biggest part of the expenses as well when it comes to building, especially in concrete. And the possibilities of reduce 20% to 30% less in a precast concrete building compared to in situ casting, and in combination with the possibilities of reducing the amount of steel used, makes actually the building solution more economical than if we would talk about building in situ casted, for example. At the same time, we have a solution where the building is faster and requires less manpower. Precast concrete construction is an industrialized manufacturing method, and it is a combination of different pillars and combining the optimized use of material, an optimized design, and optimized production. In combination gives a good quality, and as a result, we have actually a possibility to talk about manufacturing instead of traditional typical construction. The better use of raw materials is taken into consideration, of course, the local raw materials available in the area. The exact mix design will be actually also provided to each factory, depending upon what kind of materials are used for the different projects. Of course, these materials are, of course, according to standards as well, and the use of these materials in combination to the production is following international standards and national standards regulated by municipalities and also different associations, governments worldwide. Precast concrete gives architectural freedom, and Burj Al Arab, for example, is a good example of how you can actually have different shapes, forms in combination with precast concrete. The productivity is better at the factory and also at site, and the material flow is more straightforward as well. It's a controlled process, and the whole process actually gives transparency also for the project owner to have a look at the total expenditure of the whole project from design stage to the actual buildings. In this way, it will be possible to actually forecast what will be actually the cost of a building already at the design phase. At the same time, when we're talking about the speed of construction, it will give faster return of investment for any contractor going for this kind of building method. The BIM modeling optimizes the construction process, and the cost of the design and the modeling in itself is actually fairly low compared to the overall building project cost. At the same time, the cost and focus and the energy resources put into the project in the design phase will certainly represent savings throughout the cycle of the production. During the production process, there will be possibilities to actually already implement the ideas of detailing from the BIM modeling. From the model, again, each part of the building is fed into the system of the precast concrete factory, and according to the manufacturing execution software, the parts of the precast concrete building is manufactured. And from manufacturing, the parts are sent to the site and installed at site. The parts are, of course, assembled together using industrialized and tested connections, and these connections, starting from wire loops, column beam shoes, for example, delta beams, are something that ensure also the rigidity and a long lifespan of the building. And the overall installation planning, management, and coordination is in line, of course, with what has been planned in the first place. So actually everything from the design, production planning, invoicing, all to the quality control at site is actually covered by the process. A brief view of the grand views. And I'm going to present you the grand views at Millennium Estate, Meydan, Dubai in United Arab Emirates as a case study. Actually, the developer and CEO stated this project to be raising standards a notch higher than the rest. Often talking about precast concrete, we associate perhaps sometimes low-cost, affordable housing and so on. But this case study is showing also that precast concrete can be used actually in a very interesting way, and is not all the time actually the cheapest possible end solution from when it comes to the actual building. Of course, the cost of construction is at a certain level, but actually the end solution, depending upon the design and the finishing, may actually represent luxury buildings, as in this case. The precast design and manufacturing is done by United Precast Concrete in Dubai, and the number of units in Grandview's project in the Meydan area is a total of 475 units, comprising of 171 villas and 304 townhouses. Some of the villas have an elevator, 3 stories, and all of them have, of course, all kind of small backyards and different solutions to make the area interesting whatsoever. The Meydan area is located in Dubai, quite close to the Meydan racetrack, roughly 5 kilometers from Burj Khalifa, towards the direction of the desert. The project started in 2016, it was completed 2018, and the time was a total of 18 months for this project, starting from the design phase until the completion of the project. The precast project value was 225 million dirhams, as the project value in total, according to College Times and the National, for example, was 2.65 billion dirhams. Here we see a visualization of the project, how the developer thought about the project, how to locate the houses, the infrastructure and everything, and going to the actual project. The selection of construction method was, of course, one crucial thing at the very start of the project, when the developer actually wanted to start the project. Of course, they needed to look into all kind of possibilities how to make it happen. But some clear points were actually pointing towards the use of precast concrete. One crucial element was to save time. So the speed of building to get a completion of the whole project within 18 months was accomplished by building 1 villa and 2 townhouses per day. The cost savings during construction was, of course, pointed out. And of course, looking into precast concrete, the optimal use of raw materials, less needed finishing, no needed plastering, was a crucial point also why the decision makers were leaning towards precast concrete. Again, long-term maintenance cost savings was a clear point. High quality was required, as this project actually represents luxury living, and there would be no compromising in the quality. And of course, to reduce manpower at site as well, because this amount of villas being developed within the short time period will actually put quite a lot of load on local network, road network, and coordination at site as well. So these details actually were leaning, or making the developers leaning towards the solution of making the whole project in precast concrete, which was also the case. The Grandview's project was built using load-bearing walls and hollow core floor slabs, and also the roofing is actually hollow core floors or hollow core slabs. The total amount of precast concrete panels being casted and made in UPC Dubai was 77,900, and the average amount per unit, average amount of precast concrete panels is 164 pieces. All panels are pre-designed and they are including the mechanical and electrical and plumbing, internet cabling, and so on. And this makes, of course, installation at site much faster. The installation at site, of course, is also taken into consideration the already casted connection parts, which make it possible to actually connect the panels to each other according to international standards. The sandwich panels are actually the part of the facades, and the facades are 250 millimeter load bearing with 50 millimeter of insulation of polyurethane built in. They are made by actually double casting in the way that first the facade part is casted, then you add the insulation, and then the load bearing part is casted on top of the insulation. When you lift up the panel, you then have actually the complete sandwich panel, and already at the factory, of course, all the window openings, door openings are installed or prepared. The insulation of the wall panels represent actually a U value of 0.32 watt per square meter and per Kelvin. And actually, the U value, that is a measurement which is actually measuring how much comes through 1 square meter of a Kelvin grade. So that means that the lower the U value is, the better is the insulation for the house as well. The insulation is very important in Dubai, despite the fact that it's warm. Also, in the whole area of Middle East, we're talking about warm climates, okay, but still you will need insulation because you don't want the hot air to come inside. Up in Nordic countries and in some parts of the world, we have the other solution that there is cold air outside, which we want to leave outside and have warm air inside. But as a matter of fact, it takes more energy to cool down a house than to heat it up. So with heating, you can actually go with a lower amount of energy to get it to an acceptable level. But to cool down the housing, it requires actually much more. And as an example, in Saudi Arabia, at some point, almost 70% of the total energy consumption went into cooling down buildings. So nowadays in Dubai and also in most countries in the Middle East, it is compulsory to actually apply insulation in all concrete or in all wall facades. The panels which were developed and delivered, they are of grey concrete and painted at site. Of course, the facade can look different also if you choose colored concrete. And for example, even if you sandblast the facade, then you will have the aggregates visible. That can be sometimes interesting if you have the aggregate taken from that very area where you're building the houses. And then sandblasting the surface, you will actually see the actual stones from that very area. It is possible to, of course, grind the surface, grind the concrete. That will give like a marble-like finishing, granite-like finishing. Then it's, of course, possible to use, for example, graphic concrete, which is a combination of smooth and exposed aggregates, to have different kind of patterns or texts in the wall. Or it's possible also to have foam liners, which gives a three-dimensional pattern in the facade. In the project, there were also solid wall panels of 150 millimeter and 250 millimeter of load-bearing solid walls. And of course, also 100 millimeter of non-load-bearing walls as well. The parapets are of 120 millimeter solid concrete. Hollow floor slabs used in the project was a total of 155,250 square meter. All these hollow slabs were produced in the factory by using an extruder. So the extruder is giving actually the best possible compaction, and it is actually casting the pre-stressed hollow slabs with a pre-stress level of more than 1,000 megapascal. The concrete mix is very dry, so we're talking about the dry mix when it comes to producing hollow core slabs. The hollow core slab, as the name tells you, it's a slab with voids. The idea of using the voids is to actually minimize the use of concrete and also minimize the use of cement when it comes to producing them by the extruder. So then you can save also cement in the concrete mix. But as a matter of fact, the voids are actually there to make the slab lighter and not compromising the load-bearing capabilities of the slab in itself. For example, the weight of 1 square meter of the 200 millimeter hollow core slab is 239 kilos. And the voids makes it possible, so that means that actually for the 200 millimeter hollow core slab, almost 50%, 49.9% of the surface area of this 200 millimeter is actually representing the voids. So that means that looking at the cross section of the hollow core slab, almost half is actually air. And this means that the slab is as light as possible and still not compromising the load bearing capabilities. As a result, it is of course very capable of bearing the loads. There will be actually no cracks as it's designed according to international standards. And at the same time, the use of steel is minimal because the steel reinforcements are actually the pre-stress wires. There are no mesh needed except from on the topping, of course. After installing the hollow core slab, there will be a topping on top of the hollow core slab to actually tie them together and give it more shear strength. But nevertheless, the load-bearing capabilities lies in the pre-stressing of the hollow core slab. On the left-hand side, you will see actually a graph, and here we can see that as an example, this is the 265 millimeter curve, the capacity curves of the hollow core slab 5 void 265 millimeter. It's possible to actually reach a length of 10 meters and still actually have roughly 12 kilonewtons per square meter actually on as a performance. The length of the slabs applied in Grandview's Maidan were actually varying from 1.2 meters to 9.4 meters. So actually the products used, the 200 millimeter and 265 millimeter especially, they could have actually allowed even longer spans in the whole project. The completion of Grandview's was, of course, considered as a success because it was completed in 18 months. It's there. You can all go and have a look at it if you like. But of course, nothing comes in that sense without challenges. And the major challenges during this whole project were actually partly linked to the logistics. And the fact was that the road works were actually ongoing when also the installation of the houses, of the villas and townhouses were ongoing. So that means that the trucks delivering heavy precast concrete slabs, facades, internal walls needed to drive on the sand. And that caused, of course, some challenges when you have soft terrain underneath. Partly linked to the logistics is also the stockyard management at the factory. We are talking about the huge number of panels, and to control everything is challenging. But of course, thanks to the management execution software used, it was possible to locate each and every panel which was supposed to be installed at site, and also where it's installed at site at the end of the day. Also regarding the logistics, the precast concrete manufacturer was not the only one at site. There were also, of course, other companies installing the lighting, street lighting, and plumbing, everything regarding the infrastructure as well. The acceptance procedures was considered to be a bit challenging because it turned out that some let's say parts of the developer and some key personnel actually did not know exactly 100% that they could be authorized to actually hand over a part of the building, because they wanted to really thoroughly examine that everything was built according to standards. So the acceptance procedures were something that the precast concrete manufacturer really did a great deal to actually get smoothly and running. Safety management, of course, was an issue, but luckily there were no major issues related to safety at site. But the safety management was something of a concern, and thanks to a good job done by the security personnel and also by all involved, there were no really fatal issues at site. The completion was by deadline, and it showed good teamwork between all parties involved in the whole project. Of course, the clear success was the quality as well, and especially visiting some of the villas, including the private elevators, you get a feeling of a posh environment. You get a feeling of luxury, and this was the target of the developer as well. The street view in the background, of course, is not completed yet. Some of the infra is still missing, but still at that point, all the buildings were ready and standing. As conclusions, it's quite clear that good precast design represents savings. So doing a good homework prior to starting the whole project, that will clearly represent savings for running the production process and also for the installation. As we just also noticed, the logistic part is at a crucial point. So that means that a good design and also good planning minimizes all kind of headache at the end of the day. We also know already that all types of buildings are possible to build with precast. And actually it's possible to build all types of buildings with precast all around the world. So for example, typical buildings, shopping malls, schools, offices, hospitals, are quite obvious, but in addition, it is possible to go for luxury villas, and it is possible to actually also build affordable housing with the precast concrete. And again, some people also these building solutions are affordable. With precast concrete, we get fast return of investment. So that means that the developer will, at the end of the day, feel confident that his funds, his money is not out in the field for too long, and not creating revenue and more business. The insulated buildings lower life cycle costs, and one calculation was that the use of insulation, the extra cost of the insulation in the facade compared to a building without the insulation will actually pay itself back in 6 years only. So that means that if you build a villa without the insulation, so in 6 years you would have spent as much as it would have cost to have insulation for that very same building in the first place. Long floor spans reduce steel, concrete, and cement. The long floor spans also makes it possible to have a different kind of variations in the rooms. So instead of having load-bearing interior walls, you can actually then have non-load-bearing interior walls. If your family situation requires you to have, for example, 3 or 4 different rooms for children or whatever. So when the situation changes, or let's say when one family moves out and the other family comes in with the requirements for less rooms, but the desire of having bigger spaces, it is possible to tear down some of the non-load-bearing walls to create the more space as well. The quality, the build quality, which is ensured by controlled processes in the factory, and of course also the supervision at site when it comes to the connections, they provide longer lifespan, and that gives a more secure investment for the owners. So there is no risk of having a balcony falling off or having a clear crack in the middle of the wall with the precast concrete buildings. Of course, using industrialized construction methods provide long-term competencies as well. So that means that it's not only the question of putting one block on top of each other and then plastering. The overall management of a precast concrete construction gives long-term competencies to everybody actually in the building process. From the architectural visualization to the actual ready buildings, we can actually conclude by having a look at the flyover of the Maiden project. And of course, those of you who are in the neighborhood, you can actually go and have a look yourself. After the flyover, we can then discuss possible topics, and I will answer any questions. Thank you for attending this part of the seminar, and I'm now happy to answer any kind of questions.
A truly excellent and fascinating session there. Thank you so much once again to Curt Lindroth, the Area Director at Elematic, who is still here with us to continue the conversation and to answer some of your most pressing questions on the precast concrete market, which, as was mentioned, is set to grow at a compound annual growth rate of 6.3% from 2020 to 2027. A huge projection there. Thank you so much once again to Curt. And we have had quite a few questions come in. So let's start off with our first question. Why should a project owner give preference to a precast concrete compared to other solutions? Why should a project owner give preference to precast concrete compared to other solutions, Curt?
Thank you. It's actually a question of the desired end result. If the target is to have actually a project within a reasonable time with the best possible quality and also at a reasonable cost, it starts to lean towards the solution of using precast concrete. Also, as a matter of fact, as it's a proven solution following in international standards, it means that it's quite safe to lean towards. But please take an attention and keep the design actually reasonable, because when you focus on the design, you can actually follow through the project actually quite smoothly. And using the BIM modeling, it is actually transparent as well as for the whole project. There will be no loss of material at site, for example, and in that sense, we are minimizing the workforce at site.
Really interesting. Very quickly, before we move on to the next question as well, what's the difference between precast concrete and precast stone? Are they very similar? They're using the same sort of building constructions as well?
Well, as a matter of fact, going a little bit off the question first, in the UK, often precast is referred as liquid stone, or let's say concrete as liquid stone. I love the definition in a way. But going into, for example, the precast stone in such, you could associate it to, for example, a ready-made block. So then actually, if we're talking about a prefabricated block, then we're more or less talking about in situ casting, basically, where you cast in situ columns and beams, and then you fill the gaps with the ready-made blocks, with the sort of like precasted blocks. These can be insulated as well, but going into a full precast system, we're talking about quite often in for example, villa projects, about load-bearing walls and then hollow slabs as floors and roofing.
What about 3D printing with cement materials as a tool for producing free-form precast formwork? Have you considered 3D printing with cementitious materials as a tool for producing free-form precast formwork?
I'm actually following the topic, and it's exciting to have the opportunity of modern technology in building and construction. Typically, it's a very conservative field, but 3D printing could represent at the factory, for example, a print of decorative elements. But taking the whole 3D printer at site and then to print the whole building, it goes for, let's say, smallish projects. In Dubai, there are a couple of small buildings. Also in Sharjah, there is a building actually which has been 3D printed, but it's not yet as defined as precast concrete construction. It's not yet an industrialized solution by definition. So it still is in its baby shoes and taking baby steps forward, I think. But certainly, also when it comes to precast concrete construction, it is possible to combine different building methods, like for example in Burj Al Arab, where precast is one part of the building and other solutions is applied as well.
It's still very much in its infancy and definitely one to look out for that. So how does precast concrete wall installations, how do they compare to traditional materials then?
The wall installation, when it comes to precast concrete buildings, require lifting capabilities. So typically at site, you will see cranes, and the cranes are defined as per the loads that they need to lift. So that is a little bit depending upon the design from initial phase. Sometimes mobile cranes are used if the building is not very high, but in high-rise precast buildings, which can be even up to, for example, 40 floors. There is an example actually in Dubai also of a full precast building with load-bearing walls, which is going up to 40 floors. Compared to, let's say, traditional building in situ casting with the in situ casted columns and beams and blocks in between, you don't need that heavy lifting equipment. But then again, you have much more work to do at site, and the plastering is consuming quite a lot of water at site, and all the equipment which is needed at site is considerably more.
And our final question from our attendees: do precast concrete walls allow for attractive styles and designs?
Definitely yes, and it all comes down to the design again. So as I mentioned actually in the presentation, it's possible to apply, for example, foam liners or graphic concrete. And this is a method where you actually are pre-designing, first of all, the pattern or the picture that you want to have on the wall. And then when you cast the element, you're actually getting that very picture on the facade. It can be a picture, text, it can be like stripes, or any kind of pattern by all means.
Thank you so much. So just before we leave, it would be really...
Yes, so then again, it's also possible to have marble-like finishing by using, for example, a grinder, or it's possible to use colored concrete. So if you have colored stones in the facade, and then you actually sandblast, or by a retarder, you sort of like remove the glue-like cement part from the very surface, you will actually then see the natural stones in its original color. So yes, coloring is possible, and of course, today's paints are very durable as well. So paint will nevertheless at some point need to be sort of painted facades need to be repainted, but there are different options how to let it go.
Truly fascinating. Thank you so much. Please do leave our audience with your key takeaways. What are the key highlights you would like our audience to go away with off the back of your presentation today?
Yes, actually, the Grand Reviews project clearly show that precast concrete construction is a solid solution for production of high-end buildings as well. Often, precast concrete construction is associated with perhaps gray and dull environment, but it comes down to the design. So really, architects, please be encouraged to do something extraordinary using precast concrete. And also for business owners, I remind that precast concrete represents a fast construction method, which gives a fairly good return of investment, as it's a fairly reasonable cost linked to the precast concrete construction. The quality is high, and for example, in one project in which we were involved, we need the project owner required 200 years of structural warranty for that very building, and he got the warranty, of course.
Brilliant. A fantastic conversation and presentation there with the area director at Elematic, Curt Lindroth. Thank you so much for your time and for being with us here today. And of course, we do hope to see you in person next year. Thank you so much once again.